I'm going to present details about the scheduling. If you take the processor or CPU, which is having many processes running, so the CPU handles this process, processes using the scheduling mechanism. So, like scheduling assigns one process for the execution and keeps the other process in the waiting. So they can be in the four stages like running, terminate, waiting, and the ready. For example, one state you can take it's changes the process from the running to waiting. For example, IO request, application await for the termination of the child processes. Under this case, one state will be done. Another one is for transition. Another second transition. This transition will change the process state from the running to the ready. So this when the interrupt occurs, then it will be shifted to the ready state. Another one is when a process switches from the waiting state to the ready. One is waiting and is into the ready state, and when the process is terminating. So when a scheduling takes place only under the circumstances 1 and 4, we say the scheduling is non-preemptive. Otherwise, the scheduling is preemptive. And scheduling algorithms, we have many scheduling algorithms, like I listed the six. So we are going to, I am going to explain the scheduling algorithm in the subsequent slides. Question first comes first serve scheduling algorithm. With this scheme, the process that requires the CPU first is allocated to the CPU first. So as we see, there is a three processes are there. The first one is saying 24 burst time, second one third and third. The first time is the time which is required for the CPU to execute the processes. So this I represented in the grand chat as a time sequence. The first P1 is has come, so it is taken 24 seconds, and the next is 23 seconds, and next is 3 seconds. This is the time, and the total time is 30 seconds, and the average waiting time is will be 17 milliseconds. And if the sequence is changed to P2, P3, and P1, then the execution will be like this. So 3, 6, and 30. So by this, the higher time, higher burst time process will be waiting the very less time. FCFS scheduling is non-preemptive. FCF scheduling is particularly troublesome for the time-sharing system, where each user needs to get the share of the CPU at regular intervals. It would be disastrous to allow one process to keep the CPU for an extended period. So next is shortest job first. When the CPU is available, it is assigned to the process that has smallest next CPU burst. If two processes have the same length next to CPU burst, FCS scheduling is used to break the tie. For example, if you take the top four process P1, P3, P4, so if you see this one here, the burst time is having shortest is for P4. So first P4 is executed. After P4, if you see for P1 is having next. So P1 is executed. After P1, P3 is having 7. So P3 is written. After that, P2 is executed. So this algorithm sometimes called the shortest remaining time for scheduling. So SRTF, this algorithm can be preemptive or non-preemptive. So whatever we discussed in this left side is non-preemptive. And if we come into the preemptive process, if you see I have taken the four examples P1 to P3 before, and this arrival time and also burst time. So in the previous we don't have arrival time. Here if you see first P1 has arrived, so P1 start executing. After executing 1 second, the system has seen that P2 has arrived. But P2 is having only 4 bursts. So this is less than the pending. So 7 is there. So P2 is executing. So at the time interval of second, P3 has error. But P3, if you see, it is having 9 burst time, but already 4 is executing. So it can argue. But after P4, 5 has come. So it has given the priority to 5. So it is start executing. So when it start executing after the P1, then P3 is given the pending. After the pending is over, then it is given to the P3. Okay. Here process P2 is error. That's what is shown in the sequence. Priority. The SGF algorithm is a special case of the general priority scheduling algorithm because priority algorithm is it assigns the priority and which is more priority it will do it. So SGF is indirectly is burst time is taken as a priority. The lowest burst time is taken as a highest priority. The priority is actually with each process the CPU is allocated to the process with high priority. Equal priority processes are scheduled in the FCFS order. An SJF algorithm is simply a priority algorithm wherein the priority is in the inverse of the next CPU bus. The larger the next CPU bus, the lower the priority and the vice versa. Priority schedule algorithm can be preemptive or non-preemptive. When a process arrives at the ready queue, its priority queue is compared to the priority of the currently running process. A preemptive priority scheduling algorithm will preempt the CPU if the priority of the new alive process is higher than the priority of the currently running process. A non-preemptive scheduling will simply put the new process at the head of the Redis queue. Round robin scheduling generally involves it fixes the time quantum which it is to be executed. So the process are put in one circular queue. So one by one process are executed and put at the end of that queue. So that queue is can called as FIFO. For example, if you do here P1, P2, P3 and is assigned the time quantum of the 4 seconds. And if you see the first one P1 is executed after 4 seconds, P2 is executed, then after that P3 is executed, then P1 is continued here since there is no pending. If there is a pending is in another one, it will not continue. So as the time content decreases, then the load due to the context switching is increases. Multi-level queue scheduling is another scheduling mechanism wherein the processes of the system are divided into several classes, and each class is assigned with a one type of scheduling algorithms. So, for example, here you see in the system we have the many process, system process, interactive editing process, batch process, student process. So, the system will will assign the scheduling based upon the process activity which is going to take for this each class. Like for example, one system process may have round robin scheduling, another one is FCFS scheduling, another one has a priority scheduling, another one is shortage job fasting. So that we can reduce the timing. But in multi-level queue scheduling algorithm, processes are permanently assigned to one queue and entered to the system, and they are not changed to the other queue. So this has the advantage of low scheduling, but the disadvantage of being inflexible. So multi-level feedback queue scheduling, however, allows the process to move between the queues. This idea is to separate the process with different CPU burst characteristics. If the process uses too much CPU, it will move to the lower priority. Similarly, if the process that waits too long, it may be moved to high priority. This form of scheduling prevents starvation. This is an example. The first two is using the round robin, but the first one is having a the quantum of 8 seconds, and the second one is having a 16 seconds. And FCFS scheduling algorithm is used. Solaris 2 and Windows 2000 uses preemptive priority based scheduling algorithm, and with support for the real-time threads. Linux process scheduler also uses priority based scheduling with real-time support as well. Thank you.